morning, everyone. Thank you for joining us today. Welcome to our second webinar of 50th anniversary webinar series. First of all, we would like to thank all the attendees for joining this webinar. And I would like to state that this webinar is being recorded for marketing and educational purposes. You will receive a copy of recording in the following days. Let me introduce myself first. I'm Kaan Aytakoglu, and I'll be hosting this webinar. And I'm one of the marketing specialists at Essential Software Solutions with my colleague Anna Ciccarelli. As we celebrate the 50th year of ESS, we are proud to deliver the best and honest ERP evaluations, and we are thrilled to work closely with you every step of your ERP journey. And also, I would like to say that we are grateful to our dedicated workers, dedicated business partners, and valued clients for accompanying us for this 50-year journey. And today we are hosting the second webinar of the year, and Brandon Evans, our senior manufacturing consultant, will share insights into the futures of Infor Cloudsuite's advanced planning and scheduling functions. He's serving as a senior manufacturing consultant at Essential Software Solutions with a rich educational background, including a BCIT Business Operations Management and Diploma, and a bachelor degree in Business Administration, and CPIM certified in Planning and Inventory Management certification from ASCM. So he brings a wealth of knowledge and expertise to the table. At ESS, Brandon has played a crucial role as a senior manufacturing consultant and providing invaluable expertise to a diverse clients, both within Canada and internationally. And his focus on planning, scheduling, production, and inventory management has led to the successful implementation of tailored solutions for numerous companies. And before we begin, I would like to provide some information about the Zoho webinar platform. If you have any questions, please, you can simply type them in the Q&A section. During the presentation, I will not interrupt you, Brandon, but I'll address all the questions at the end of the webinar. And additionally, if you have any questions after the webinar, please feel free to text Brandon, so he would be glad to answer it. Okay, Brandon, so we can start whenever you're ready.
All right, thank you, Kaan.
That's me.
Just going to go ahead and share my screen here. Okay, can everyone see my screen?
Yes, we can see your screen.
Yeah, is it the PowerPoint slide? Sorry, I'm not able to see it on my end.
Yeah, it's the PowerPoint slide.
Okay, perfect.
Yes, and our attendees confirm that.
All right. So good morning, everybody. See some familiar names in the chat here, some unfamiliar as well. So for those of you that I haven't met, it's nice to meet you. My name is Brennan Evans. I'm a senior manufacturing consultant at Essential Software Solutions, as Kaan said. My experience is around pretty much all the different operational areas of Sightline, but with a particular focus in planning and scheduling modules. My background before I worked in consulting was actually in production planning and production control as well. So I've definitely got some practical experience in that area. So the session that we're going to be reviewing today is Infor Cloudsuite APS, Advanced Planning and Scheduling. Just some of the basics as far as what it actually is, what it does, how it works, how it differs from MRP, and the use cases for when to use APS, as well as some of the advantages that you'll gain from implementing. So for those of you that have worked with me before, some of this might be some stuff that I've already talked to you about, but hopefully this is going to provide a new perspective. And yeah, if you have any questions, feel free to write them in the Q&A. If I see them, I'll answer them during the session. Otherwise, we'll leave them till the end. So let's get started here. All right. So APS, Advanced Planning and Scheduling, is a material planning system. So a couple of things I'll note about the material planning system's functionality and methodology as we get into this is that all material planning systems, regardless of what they all have essentially the same objective. The objective of any materials planning system is to essentially deliver your finished good product to the customer on time when they need it. Secondary to that is to be able to provide the customer with reliable delivery dates that you can meet beforehand, so that you're able to project your availability ahead of time. In order to meet the objective, you need to know as a business what materials you need, whether you have any materials on hand or whether you need to source them, and how far in advance you'll need it. So any material planning system will perform calculations to determine what materials you need to acquire, either through purchasing or production, and when you need to acquire them. So that's kind of the basics of what a material planning system actually is. Just want to spend a minute here talking about the different material planning methods. One of the methods is engineer to order. Engineer to order, for those of you that aren't familiar, is essentially project-based manufacturing, where you don't know what your bill of materials looks like until the order actually comes in. Therefore, you aren't able to be proactive and plan ahead of time as far as parts and sub-assemblies, generally speaking. Obviously, in some cases, you know that there's common parts that you'll use. But for the most part, in an engineer-to-order environment, you source the materials once you have solid customer demand for a specific finished good. Reorder point replenishment is a little bit different. Reorder point replenishment is essentially using non-planning, so not using MRP or APS methods to acquire materials needed for production. Essentially how it works is you hold inventory levels of the parts that you would need to procure or build as part of the assemblies and raw materials going into finished goods. And when you hit certain inventory levels, which we call a reorder point, that will trigger a replenishment order. So no planning involved there. It's pretty simple how it works. When you hit a certain inventory level, that triggers a reorder. The next method is visual replenishment, also known as Kanban for a lot of organizations. Visual replenishment, a really common method of using this on the shop floor, is 2 bin systems. So you have 2 bins of the material that you need. When one bin is empty, that triggers you to move the other bin to the front of the stack and order material to fill the extra bin. So pretty straightforward there. Now, the other 2 planning methods that we're going to focus on today are MRP and APS. MRP, most of you in the call here are probably familiar with. MRP has been around for a long time. We'll talk a little bit about that later, since the 1960s. Material requirements planning, essentially how it works is it determines a due date for an end demand, and it will backwards plan based on the lead times that you assign to components and raw materials and manufactured parts, and determine a date where you need to release orders to purchase or build. APS works in a similar way, but it takes it one step further, and APS will consider whether or not you actually have enough time to build something by a date that you have requested your planning system, and it'll make a recommendation on the soonest possible date that you could build or buy based on the constraints in your system. All right, so just a few planning terminology phrases I just like to cover really quick before we get into this. Backward planning and forward planning. Backward planning means counting backwards from the due date. So if you have a 30-day lead time item and your due date is in 40 days, backwards planning will count back 30 days from the due date, and it will tell you to place an order for that item in 10 days. Forward planning is what it sounds like. It's the reverse. Forward planning is counting forward from today's date. So if we were to start today, if we were to place an order today or start production today, what is the soonest possible date that the product could be available for sale? Finite planning and infinite planning, a little bit different of a concept. Finite planning refers to capacity constrained planning and scheduling, whereas infinite planning refers to planning and scheduling that does not consider capacity constraints. So in Sightline, CSI, Sightline, I usually refer to as Sightline. Infor sort of flip-flops between the two names for the software. CSI stands for Cloudsuite Industrial. Some of you may know it as that. So in CSI, you've got a variety of different planning tools available to you. One thing to keep in mind is planning and shop floor scheduling are completely different processes in Sightline. Some of the tools will accomplish both planning and scheduling, and some tools will only accomplish one or the other. So the first option when you're determining how you want to plan in your system is using MRP. MRP, like I said, has been around for a long time. Most people can do it on pen and paper. The way that the system calculates MRP is pretty straightforward. Like I said, it essentially sets a order date or a release date for a job or purchase order based on the lead time and the due date that's been defined in the system. The second option is MRP with the scheduler. I won't get into the scheduler too much today, but the scheduler is an additional tool in Sightline that allows you to perform shop floor scheduling. So one thing to keep in mind about MRP, MRP only performs material planning in the system. MRP does not perform any form of shop floor scheduling. So if you want to utilize shop floor scheduling in Sightline with MRP, you need to implement the scheduler. Option number 3 is using APS Infinite. So APS has a little bit more options as far as functionality than MRP does. APS is capable of planning and performing shop floor scheduling. So if you implement APS Infinite, you do have the option to perform scheduling as part of your planning process. Option number 4 is APS Infinite with Sightline Scheduler. This is an interchangeable option with option 3. You're still using APS Infinite for planning, but you would be using Sightline Scheduler module for the shop floor scheduling side of the business. There are some nuances on when it's right to use APS for scheduling versus the scheduler. It really depends on your requirements as far as achieving efficiencies and minimizing setup time or sequencing work, etc. I'm not going to get into that today, but there are a list of recommendations on when it's right to use scheduling in APS versus the scheduler. Option number 5 is finite APS and using finite APS for scheduling as well. Like I mentioned a few minutes ago, finite takes capacity into account, whereas infinite does not. So if you are constrained by a specific area on your production floor, finite APS is a really good way to create accurate scheduling and planning environments to reflect what's actually occurring on the shop floor. Option number 6 is using APS Finite with the scheduler. Again, it's using the scheduler to achieve the shop floor scheduling side of the planning functionality, but it essentially meets the same conditions as option number 5. Option number 7, the final option, repetitive manufacturing. I won't get into that today, but what I will say is that it involves utilizing production schedules on the shop floor to perform repetitive manufacturing tasks and costing by a work center rather than by job order. All right, so just going to provide a little bit of background about material requirements planning. It was developed by Joseph Orlicki in the early 1960s. So like I said, it's been around for a very long time. Earlier computerized versions of inventory management have existed since the 1950s. So it's definitely, this is not new technology. The first commercial use of MRP was by Black & Decker in 1964. A lot of companies are still using MRP today. Some of our customers are using MRP. Definitely the push from Infor these days is to move towards APS. However, for some companies, some of the requirements of APS can create complications in the accuracy of planning and scheduling, and for those companies, MRP is selected. So MRP, I mentioned earlier, MRP only performs backwards planning. MRP does not take capacity into account, so it uses infinite planning methods, and there is no shop floor scheduling component for MRP unless you implement the scheduler. So one of the big differences between MRP and APS is MRP is not sensitive to real time, to today's date. So I mentioned a scenario where MRP will tell you to release an order in 10 days if you have a 30-day lead time and your due date is 40 days from now. However, if you have a 30-day lead time and your due date is 20 days from now, MRP will tell you to release 10 days ago. So MRP doesn't have any notion of projected delays. MRP has no problem planning into the past. And the assumption with an MRP system, if you're using it, is if you get due dates that are in the past, it means that you need to figure out a way to flex your capacity or to expedite the order. That's a little bit about what MRP is and how it works. Now, the next question is, what is APS? APS is, by Infor's definition, it's a solution to a specific goal, and that specific goal is to deliver in full on time, default. So APS functionality, it revolves around a tool called available to promise, which essentially means that when you place an order or when a customer places an order with you, you can use APS output to determine what is the soonest possible date that you could meet that order and what are you able to promise to the customer. So in the ideal world, you tell the customer this is when you can get it, they accept that date, and you can deliver in full on time 100% of the time. Obviously, in the real world, things happen. There are unscheduled delays and material shortages and stuff like that that require you to change some things on the fly on occasion. But in a perfect world, using APS the way it's meant to be used results in 100% delivered in full on time. So APS will do three things, and these are the advantages of using APS as opposed to MRP. Some of the advantages: APS will help you make a good promise when you take the order. APS will help you plan supply in a just-in-time fashion to keep that promise. And APS will alert you if you are in danger of not being able to keep the promise that you've given to the customer. So that's what APS does do. Now, what doesn't it do? A lot of companies think that APS is the next step after MRP, but it's not. MRP and APS are meant to fill different needs. MRP is suitable for a make-to-stock environment where you want to achieve production efficiencies, level load production, minimize setup, stuff like that. APS, I'm not going to say that you can't do any of those things with APS, but those are not the primary goals of APS. The primary goal of APS is to build what you need when you need it so that you can deliver in full on time. So APS is not fast MRP. It is not advanced MRP. It is not next level MRP. It is a different solution to fill a different need. APS isn't designed to maximize labor or machine utilization. So from an APS perspective, there's no issue with having a resource sit idle if it's not needed. With that being said, APS will work with capacity constraints that you input into the system if you're using finite APS. APS is not designed to level load production. However, I'll say as a caveat, you are able to use tools in Sightline to create a level loaded production profile that APS will consider and use. Some of the tools that you can use to achieve that include master production schedules or forecasting for independent items. APS is also not designed to minimize setups. Again, a caveat I'd like to mention is with Sightline scheduler tool, you can perform some batching and setup minimizing that will fall within the confines of APS. So this is something that I wanted to give its own slide. We really want to drive this point home because This is something that some companies have trouble accepting. There are no combination of settings that will make APS work against its core programming. So if you as a business are not prepared to prioritize delivering orders in full on time, then you may want to consider if APS is right for you. All right, I'm going to get a little bit into the functional area of how APS works. So APS performs planning and scheduling if you use the scheduling side of it using what's called a 3-pass planning method. And the 3-pass planning method works as we can see it here. Pass number 1 functions the exact same way as MRP. Pass number 1, APS will look at the due date that you've entered into the system, and it will plan backwards and schedule backwards if you're using the scheduling piece. It'll plan backwards and it will determine a start date based on the cumulative lead time for any parts that are required to produce a finished good. So that's the first pass. MRP does the exact same thing from a planning perspective. It will consider the same thing as APS. Do you have stock on hand? Do you have projected quantities available in time to be used? And do you have sufficient lead time to make or buy if you don't have those quantities on hand or projected available? Now, that first pass, if it succeeds and APS sets a date that is in the future, that's it. APS planning stops right there. It won't perform passes 2 and 3. So what I usually tell companies that I'm working with on APS implementation is if there are no delays in the system, APS and MRP function very similarly, and your output will look essentially the same. I say very similarly because there are some differences in terms of what gets planned first. APS will plan a full exploded bomb of a specific customer order before moving on to the next order, whereas MRP will plan at the bomb level across the system. So it'll plan all the level 1s first, and then all the level 0s, I should say, and then all the level 1s, all the level 2s, etc. So their methodology of how the two planning systems work is a little bit different, but if there are no delays, at the end of the day, the output is very similar. Where APS differs is if that first plan fails. And when I say the first plan fails, what I mean is APS attempts to do the backwards plan and schedule, and it hits today's date. So there's not sufficient lead time to ship the finished good in the time that's been requested by the customer. If that occurs, APS will do a second pass of planning. That's a forward plan. APS will look at, okay, we can't plan backwards because that would mean starting in the past. That means that due date that's been set cannot be met. Therefore, what is the best date that we can meet? Well, what APS will do is a forward plan from today's date using the cumulative lead time for any parts that are required and the time to produce a finished good. And it will determine a worst case scenario on what that projected completion date would be. We don't ever see this date as it's listed here because APS will perform a third pass anytime the second pass is performed. The third pass is another backwards plan, and it will backwards plan from the projected day that it's set internally to determine whether or not there's any slack that can be removed in order to tighten up that date. So as I said, for the forward plan in step 2, APS will forward plan based on a worst case scenario. Number 3, the backwards plan, APS will look at what can we do to reduce the lead time required to produce a finished good or source a finished good, and then set a projected date based on the better case scenario. So that's the date that you would actually see in the system. You would see a projected date that's based on that third pass. The idea with APS is you get that projected date and you let the customer know. You let the customer know that their initial request date is not going to work and that the projected date is the soonest date that you can meet the delivery requirements. And therefore, as long as you perform this step upon the initial available the promise of the order, you now still have the opportunity to deliver in full on time. All right, I'm just going to walk through some graphics of how this actually works. So in this graphic here, and this is pulled right out of the APS workbook, by the way, if you've got a copy of it, I would definitely recommend reading through the scenario, but I'll walk you through it here. So in this scenario, we've got three resources A, B, and C. Now we've got a finished good that we need to produce. So this is a manufactured item. It has three operations, and the due date is set. In this case, it's about 2/3 of the way through the day on day 3. So the first pass, as I said, is a backwards plan. So APS will take that due date on day 3. It'll plan the total lead time required in operation 30, the total, or I should say runtime, the total runtime required in operation 20 and in operation 10, and it will count backwards based on shift availability of these resources to determine a start date. So in this case, we can see that we've got a gray bar in each section here. Just I think I can show my mouse here. So this gray section for each resource, that's machine downtime or labor resource downtime. In this case, this would be, off shift. So 8 hours a day, which is usually what we see in a production environment, 8-10 hours a day would be this white section here. And then the downtime, the off shift time would be the gray section. So in this case, operation 30, there is sufficient resource availability to complete the entire operation on day 3 in time for the due date time on day 3. So the backwards plan will take that into account and schedule it on day 3. In day 2, there's enough time in the day to perform all of operation 20 and part of operation 10. So that will be planned and scheduled for day 2. Meaning that on day 1, we have some operation time for operation 10 that's required to start on day 1. Now, day 1, that would be, today's date, generally speaking, depending on the time of day that you were entering the demand into the system. Therefore, we have sufficient lead time to complete this job if we start today. So this first plan would pass. Now, in this case, there's a forward plan, a second forward plan that we're going to cover. So in this case, we've got a material shortage. So as you can see here, the difference between the backward plan and the forward plan is this backwards plan, operation 20 can start immediately after operation 10. In this scenario, operation 20 can't start immediately after operation 10 because we don't have material available. The material is not available until near the end of day on day 2. So what that means, if we were to start this job today, we would actually have some slack time where no operations can be performed while we wait for material. Because of that, it pushes out operation 20. Operation 20 can no longer be completed on day 2, as in the first scenario. Therefore, it's pushed into day 3, meaning that operation 30 can no longer be completed by the due date time on day 3. So what we see here is we now have a delay. We can't meet that due date that's been set into the system. So the second forward plan would be triggered in this case, and that's what we see here. We see here that the material availability has been taken into account, and a projected date of early in the day on day 4 has been set for this job in question. So because the second forward plan triggered due to the material shortage, we now have a projected date that's later than the due date. That means is that the third pass is going to trigger the third backwards plan. And what it does is it looks to see if it can tighten up any slack in the system. So in the second pass, the planning methodology is still setting an operation 10 start time of today's date. And then there's slack in the system where nothing can be performed. The third pass will tighten up that slack, and it will move operation 10 up to when it should be started so that the material will be available immediately after the completion of operation 10 and before the start of operation 20. So in these two scenarios, the projected date didn't actually change, but the start date did. Now, an exception to this functionality is if you've already started operation 10 at the time where you identify a material shortage, planning is not going to pull operation 10 up. The goal of planning in that scenario is to push the work in process through the system as fast as possible. But I won't get too much into that concept today. All right, so that's the way that those 3 passes work and what the scheduling would look like for the 3 operations. All right, so I'm going to run through another demonstration here. So in this case, we've got a manufacturing lead time for the finished good, as we can see here. We've got a due date here. Now, in this scenario that we're looking at, this is how MRP would process the order. So it would look at what is the total lead time for manufacturing, what is the lead time to source all the different components, and what is the start date based on the longest lead time. So in this case, component B has a lead time that runs prior to today's date, meaning that there is a release date in the past. So using MRP, what you would see is a start date that's in the past for the job or for the PO, or a due date for the PO that's in the past. In this case, using APS, what we're going to see is an adjustment to these dates to meet the reality that we can't possibly place an order or receive an order in the past. And that's what we see here. So these blue bars represent the initial dates on the backwards plan. Because the backwards plan failed, the second forward plan pushes everything up to start on today's date at the absolute earliest. So component B now starts, the order is placed today, not prior to today. So in this scenario, we've pushed out all the other component lead times by the same amount so that they're all available at the same time for the manufacturing lead time. So that would be that third backwards plan, would be pulling everything up to meet the date that's been set by component B. We can see here, the manufacturing lead time has also moved out, and we have a new projected date to match the amount of time that we needed to push up the longest lead time component by it. Right. So that's that's a simple example, a demonstration of how APS actually works. Now, I just want to spend a few minutes here talking about the different functions. So APS is the implications of using APS and MRP for that matter are system-wide. So there are a number of different functional areas of your business that will both impact APS and have an impact from APS output. That includes order entry on the due date side that's set on the customer orders. This also includes due dates on forecasts, due dates on master production schedules. Anything on the independent demand side falls under this area. Those are the inputs for APS. So those are the dates that the APS uses to plan based off of and provide projected dates that are an attempt to meet the due dates that have been set in the system. From the purchasing and the shop floor side, APS will provide inputs for purchasing and shop floor on when to place orders, when to start production, when to release work to the shop floor based on availability of materials and projected dates in the system and promised dates that have been provided to the customer. From an engineering and inventory perspective, inventory accuracy is very important with APS because APS is working with material requirements and material availability. If you do not have high inventory accuracy, your APS output is going to be based on inaccurate data, and therefore the value of what you get out of APS is not going to be accurate. Similarly, from an engineering perspective, your bill of materials and your routing need to be set up accurately for APS to be utilized effectively. If your bill of materials is wrong or if your routing times are off, then, which are obviously 2 areas of engineering output, then the output of APS into your system that will be used for purchasing and shop floor scheduling will be inaccurate as well. So essentially what we're talking about here is a variety of different inputs and outputs. So the inputs, as I've mentioned, are on the demand side, customer order lines, job orders for the demand of dependent items, purchase parts, raw materials, forecasts, master production schedules, and safety stock. I didn't mention that. The supply side inputs include the on-hand inventory, any purchase orders that have already been created in the system, any job orders that have already been created and or released, if you are a multi-warehouse or multi-site environment, any transfer orders that you've got in your system, and any project output as well. The resources are your workstations. They're the areas where production actually occurs. So the inputs into your system are the resources that you define, whether or not those resources are interchangeable via a resource group or whether they are distinct. The on-time shifts for those resources, any shift exceptions, that could be things like overtime or planned downtime or anything like that. Holidays are also an input into the system because they identify additional downtime that is not part of your regular shop schedule. Your bills of materials. So this includes, actually, I think in this case, BOM stands for bill of manufacture, which includes your bill of materials and your routing. So as I mentioned before, your run times that are assigned to each operation, are there any queue times or move times between operations that would increase the cumulative runtime for production? The material lead times, do you have a dock to stock where your materials need to be inspected before they can be used in production, stuff like that. And then there's the parameters on an item level and a planning parameter level. You can set up various parameters to impact how APS will use the inputs that you provided it. So just as an example, you can set items to be planned at the parent level, but not to plan components until you have actual demands in the system. You can set up minimum order quantities, maximum order quantities, order multiples that will impact whether or not APS will group different demands together. You can set up days supply to consolidate purchase orders. You can set up parameters in planning that will combine your forecast and customer orders so you don't double count, stuff like that. So that's all part of the inputs into an APS system. Now the outputs include your projected dates, as I've mentioned, the dates that APS is calculating you can have your customer order lines shipped or your job orders complete. APS will also provide PLNs, so planned orders of what you need to purchase or buy and when you need to release those orders by. APS, specifically if you're using finite, but to an extent you can use infinite to track this as well. APS will track and provide information on resource allocations. That includes labor and machine resource utilization, what the load profile looks like. It includes dispatch lists, shop floor schedules, stuff like that. APS will also allow you to identify supply pegging, what materials are being used for what finished goods, any material shortages that exist, and the projected availability. And APS will also provide your warning messages to indicate when changes need to be made. So those are in the form of exception messages in the system. And examples of exception messages are APS will tell you when you don't need an order that you've created, when you can cancel an order or close it. It will tell you when you should pull up an order, when you should push an order out because it's not needed until a later date. It will tell you if you have a projected late demand, amongst a bunch of other things. Exception messages will provide all the information that you need to monitor the output of APS on a daily basis. So that is the brief introduction of how APS works and what it actually does. What I'd like to do is I'd like to open up the floor to any questions that anyone has. If you would like, you can speak up and I'm not sure if you have the ability to unmute yourself and ask questions, but you're welcome to if you do. Otherwise, you can post questions in the Q&A and I am happy to answer.
Mm-hmm. So please don't hesitate to ask your questions at the Q&A section. When we wait, actually, we have some questions, Brandon, about APS. Let's see what people asked. What's the benefit of finite scheduling as compared to infinite scheduling, and could I do both?
Yeah, so finite planning and scheduling, the benefit of using finite as opposed to infinite is the ability to work under capacity constraints. So with finite APS, you can essentially set certain workstations, resource groups up as unable to exceed 100% utilization. So if anybody in the call is familiar with theory of constraints, it's essentially using that methodology to schedule your shop floor. As far as whether or not you can use finite and infinite APS together, the answer is yes, you always should. Infor's recommendation is to never exceed more than 30% of your resources and resource groups set up as finitely planned and scheduled. And the reason for that is just as you reach higher and higher levels of finitely scheduled resources, the requirements from a data management perspective and accuracy of your runtimes, of your receipts, of your data entry from job orders, purchase orders, customer orders into the system becomes that much higher, to a point where it's really difficult to keep things accurate. So the recommendation from Infor is to keep the finite resources and resource groups capped at about 30%. And the goal is, as far as what you should set up as finite, is identify what your bottlenecks are on the shop floor. And that's where we use our theory of constraints methodology to determine what is limiting production on the shop floor. That's where we will map out capacity constraints. The areas of your shop floor that are not constrained by capacity, in effect, they will be using finite APS as well, because they will work under the constraints of the operations that are finitely planned and scheduled, meaning that, you know, your areas on the shop floor that could run faster than your bottleneck won't, because they're working with the constraints of that bottleneck.
Okay, thank you so much. And we have other questions. This question is coming from Carl Hutchinson. When looking in the material planner, orders will not always use the items in inventory. It will suggest using the next job or purchase order being supplied. Why would it not always default to the stock available in inventory?
Yeah, I mean, this sounds like you're speaking from experience, Carl. I mean, it's hard to say without taking a look at your system exactly why that would be the case, but some examples of why APS would suggest a job or a purchase order being supplied as opposed to consuming inventory could be you've got a safety stock in that, you have safety stock levels in that warehouse. It could be that your stock exists in another warehouse that's set up as dedicated, meaning APS won't consider those quantities. It could be that it's sitting in a non-nettable location, or it could be a setup of your parameters. So for situations like that, I would have to take a look at the specific scenario to be able to identify exactly why that is. But APS is definitely configurable to the extent that you can have it react to inventory and requirements in different ways depending on the setup.
Okay, and we have one more question. In what circumstances would the preserve pre-released production date settings from the planning parameters APS form be used?
Yeah, that one, going off of memory here, if I recall correctly, that one locks dates in before planned orders have been turned into job orders. So it essentially prevents APS from changing those dates, if I remember correctly. I'd have to double check on that, though. That's a specific terminology for a specific parameter. Yeah, I can't see who asked that, but you're free to shoot me an email if you'd like. And oh, that was Bonnie. I can see that now. Yeah, Bonnie, you're free to email me on that, and I can follow up on that exact question for you if you'd like.
Okay, we have a lot of questions, Brandon. In the functions involved slide, there's a two-directional integration between APS and engineering. Does that mean that APS may update or suggest changes to the BOMs? Does APS consider actual data progress?
I'm just going to flip back to this slide here. this the slide that you're talking about, Roberto? Feel free to just post in the chat if it is. I'll start answering in case this is what you're referring to. So your question is...
He said no.
Oh.
Advance. Can you just advance a little bit?
Yeah. Was it this one?
Yes, this one.
Yeah. Oh, okay. I see what you're asking because of the two-way arrows. Yeah. So APS is not going to make changes to your bill of material, just to be clear. APS will not suggest changes to the bill of material either. What APS will do, however, is APS will, if you set up alternate materials on your bill of material, materials that could be used if your main materials are not available, APS will consider using different items from a BOM as long as you model it that way. But APS is not going to change anything from an engineering perspective in the system. APS will work with the engineering data that you input. So if that includes setting up alternate materials so that APS has the ability to choose, then it will do so. And actually, that's a good question because that is one of the areas that MRP is not capable of doing that APS is. APS can look at, do you have your main part on hand? If not, do you have sufficient lead time to source the alternate part and then make a consideration that way? Because MRP doesn't have the ability to recognize when an order is projected late, MRP would never recognize a scenario where an alternate material should be sourced. So there is a difference there. Hopefully that helps. If you had any further questions about that that wasn't answered in my response there, Roberto, you can always send me an email as well.
Okay, the other question is, can vendors be set up with specific delivery dates? Example would be the vendor only delivers on a Monday.
Yeah, I did see one other question before that from Carl as well. If you don't mind, I'm just going to quickly touch on that one. So Carl, you asked, through the customer order lines, you are sourcing jobs and having the parent job sit in firm status. This seems to straighten the planner out. So what you're referring to is a direct cross-reference between a customer order line and a job. Once you create that direct cross-reference, the customer order line is no longer planned by APS. The customer order line is linked directly to the parent job that you've set. So regardless of whether or not the parent job is in firm or release status, APS will now plan the components of the job, but not for the finished good itself in that scenario. So APS won't consider direct cross-references. And that's probably why in your case, you said it seems to straighten the planner out because APS is no longer considering planning the projected availability of that job. All right, moving on to the next question from Ted. Can vendors be set up with specific delivery dates? Example would be the vendor only delivers on a Monday. I'd have to look into that. Normally, the way that the system's configured, in my experience, is the purchasing dates are defined on a system level. So often it's 24 hours per day, Monday through Friday. Yeah, I'd have to look into that one, Ted. It's possible, but I'm not prepared to comment at this time. I think I remember you asking me that previously as well. If you email me that question just so it stays on my radar, then I can definitely look into it for you, but I'm not aware of that functionality.
I got a private message, one of our attendants, Brandon, by the way. How much does company transaction accuracy and discipline affect to the success of APS?
Yeah, so I would say that the accuracy of the transactions that you input into your system will have a significant impact on your planning environment, regardless of the planning method that you choose. Depending on the type of planning method, the impact may be greater or less. Finite APS the greatest impact from inaccurate transactions is allocated. So with finite APS, the problem, let's use an example of timely data entry. So I'm working with a customer right now who doesn't have timely data entry, and they're currently using infinite APS, and they are looking to implement finite APS. So for that customer, the issue with implementing finite is that they don't necessarily get the job order or purchase order transactions into the system for several days or even weeks in some cases. Now, if you're working with a finitely constrained production environment, every day that you don't do what APS thinks you're going to do, so if you don't enter in that you've completed a job, for instance, for several days, but in reality you actually have completed the job, every day that it sits open, it is being allocated towards available capacity. So if you don't have timely and accurate data inputs in a finite APS planning and scheduling environment, you're going to end up creating unrealistic delays in your system. Now, with infinite APS, the impact of something like that is a little bit less, because infinite APS won't push out production dates based on not having enough capacity. It will assume that you can flex your capacity to meet the production date that's been scheduled. However, if you don't enter in that you've received a purchase item, for instance, that's still going to cause a delay to what APS thinks that you can do on the production floor. So yes, one of the requirements of using a system like APS that is very robust and comprehensive is that you provide realistic information as to what's actually happening on your shop floor. But the argument that I make when I work with customers that are determining whether or not to use MRP or APS or something else entirely is, you don't escape that with MRP either, or with any planning system. If you want the planning output to be of any value to your business, you need to be telling it what's actually happening on the shop floor. And if you are not telling it accurate quantities that you're producing, or when you're producing, or when you're acquiring materials, APS is working in conditions, and MRP as well, that don't actually exist, and the output is going to be of limited value.
Okay, thank you so much, Brandon. And we have another question, and actually we still have time. If you would like to ask any questions, please write at the Q&A section, so we would be glad to answer. What if I have a multitude of resources for any given operation? Can Sightline APS schedule these concurrently or at the same time?
Just to make sure I'm understanding the question, are you saying, for example, if you have a machine and labor resource that you need to schedule at the same time, so an operator and then a machine, for instance, that need to be scheduled concurrently in order to produce a job? Is that correct?
If you send me the answer privately again, that would be perfect. Okay.
I saw a thumbs up go out. So, okay. I mean, I'll start answering assuming that that's correct. And if it's not, then Con, you can let me know. Yeah, APS is capable of doing that. If you assign multiple resource groups to an operation or a work center, those resource groups will be scheduled concurrently. So it will select a resource from those resource groups, each resource group that's assigned to the operation or the work center, and it will schedule them concurrently. And from what I've tested, there's no limit on how many you can do this for. I've tested up to 4 resource groups scheduled concurrently. I don't see why there'd be any limitation on that. I also don't see why you would need to schedule 4 resources concurrently, but definitely what I've implemented in the past with other customers is scheduling a machine and labor resource to be required at the same time.
Okay. I think we don't have any more questions. Oh, no, we have one more question. If you're trying to, it's coming from Andrew Lennox. If you're trying to level out production throughout the year, I'm assuming material planning and scheduling is the most likely approach, not APS.
So I said earlier that, I think I'll jump back to that slide here. So I said earlier that that APS is not designed specifically to level load production. However, that doesn't mean that you can't have a level loaded production environment and use APS. You just need to use some tools in addition to APS to schedule your shop floor and plan your shop floor. So some examples are using master production schedules or forecasts. Forecasts are useful if you will eventually have a customer order for that specific end item, because you can consume the forecast via a customer order, so you don't end up double producing. But master production schedules you can also use, which I know, Andrew, your organization, you are using master production schedules for certain items. And you can use master production schedules to define a build rate of your finished goods or sub-assemblies for that matter. You can set a master production schedule at any level of the bill of material that you wish. And you can essentially level load production using that strategy, because once you set a master production schedule, APS and MRP will no longer plan for that item. It will only plan for the lower level BOM items. So I didn't make a slide about this specific concept, but depending on the type of organization that you are, so engineer to order, make to order, assemble to order, or make to stock, you can use master production schedules based on forecast output for product families, stuff like that, related to sales and operations planning, to determine a level loaded production profile at either the end item level, the sub-assembly level, or the raw material level. And yeah, then you can level load production using APS or MRP.
We have 3 more minutes, but we have one last question. How does APS manage planned and unplanned maintenance when running a finite capacity?
How does APS manage planned and unplanned maintenance when running infinite capacity? Not sure I understand what exactly planned and unplanned maintenance means. Are you referring to maintenance of machines, of plant maintenance? Is that what you're referring to?
Okay, let's machine maintenance.
Machine maintenance. If it's planned, you define your machine maintenance on the shift exception. So I mentioned that earlier in the presentation. You can define shift times with shift exceptions to identify planned overtime or planned downtime for specific shifts. And you can assign those shifts to the resources. Sorry, you actually define it on a resource level, not the shift level. So if it's planned, you define it that way, and APS will just treat it like it's downtime, it's unavailable time for the resource. If it's unplanned, I mean, kind of hard to map unplanned downtime out into the system. If it's unplanned, but you know about it a little bit ahead of time, you can define it with shift exceptions. If it's unplanned and you don't know about it until the time where the machine or the other resource actually goes down, there isn't really a way to model that. That creates a projected delay on the next planning run when you don't complete the production that has been scheduled against that resource.
Okay, thank you so much, Brandon, for the answer. And okay, so the time is 10 a.m. Thank you for attending, everyone, and we would be glad to have you here today. And thank you for Brandon. It was a very insightful presentation. Thank you so much. And like I said, we sent you the webinar recording in the following days. Thank you so much and have a great day.
Thank you, guys. Take care. Have a good day.